In this video, we're going to look at how we use trigonometry to find angles within a right-angled triangle. We'll start off with a reminder about some of the terms and symbols we use in trigonometry. We'll have a couple of examples, and at the end of this video, there's a couple of problems for you to attempt, which will be covered in class. So as a reminder, when we have an angle in a right angled triangle that we're going to use within our calculations or find by calculation, we name all of the other sides of the triangle in relation to this angle. We call the longest side, which is opposite our right angle, the hypotenuse. We call the side opposite the angle we're concerned with the opposite. And we name the other side, which is also next to our angle, but not the hypotenuse. We call this side the adjacent. And we have three ratios, which we use in order to calculate angles and sides within right-angled triangles. We have sine, which is the sine of the angle is equal to the length of the opposite side divided by the length of the hypotenuse. The cosine equal to the length of the adjacent divided by the hypotenuse. And the tangent equal to the length of the opposite side divided by the length of the adjacent. And for short, we call these sin, cos, and tan, just to save a bit of time saying all the names, and that's usually how we write them as well, as they're abbreviated on the right-hand side of this slide. And here's how we write them in our mathematical notation. So we say sine B is equal to O over H, where O is the length of side AC and H the length of side AB. And we could replace AC or AB with the numbers if we know the length there, and we could replace that capital letter B with the size of the angle when we know what that is within the problem. In today's video, we're going to be looking at examples where we know the length of two sides, but we don't know the size of the angle. That'll be the thing that we're trying to find out. In order to find out the length of, the size of an angle based on the length of the sides, we need to use the inverse of a trigonometric function. So here are all our functions that we looked at in the previous slide. However, if we were given length, for example, for AC and AB, and we wanted to find angle B, we need to take the inverse of what we have here. So using our calculators, we put something like this in. We'd have the inverse of sine, and we put in that division of the length of AC divided by the length of AB. And very shortly, we're going to look at some practical examples using real values to find angles. And the practice work we did with the calculators last week, hopefully we're all in the correct settings and able to use our calculators effectively to find this information. So here's an example. We have a ladder of length 8 meters and place it against a wall, and we know the distance from the bottom of the wall to the foot of the ladder is 3.2 meters. We want to find the angle that the ladder is going to make with the ground. So first thing to do is to draw a sketch to help us understand what's happening in this problem. So here it's represented here, the hypotenuse, the longest side there, 8 meters the size of our ladder, and that 3.2 meter length is that distance along the ground from the wall to the foot of the ladder. So first of all, we locate the angle. Now we've just picked a name for angle P here. We don't need to give it any particular letter. That's been chosen arbitrarily. We called it angle P. And we name the sides relative to the angle. So as I mentioned, because the ladder, the 8 meter length, is opposite the right angle, that's the hypotenuse. Because we're working with angle P, the other side that's next to the angle is not the hypotenuse, is adjacent. And of course, the side which represents the wall is opposite the angle, and so that's our opposite side. So we're wanting to find angle P, and we know two pieces of information. We know the adjacent and we know the hypotenuse. So this is enough information to tell us which one of sine, cosine, and tangent we need to use. And before I reveal it, you might want to write down or even think to yourself what it is. just to check that you would know this yourself. Well, if we consider our SOHCAHTOA, we'll see that it has to be cos that we use, because cos is the trig ratio that works when we have adjacent hypotenuse. That's the CAH. So that allows us to solve this problem. What we can do is write out the rule for cos, which is cos of the angle is equal to the adjacent over the hypotenuse. We can put in the numbers we got from the question. 3.2 is the adjacent, 8 is the hypotenuse. And if we put this into our calculator using either the second function or shift button and press cos, put in 3.2 divided by 8, close our brackets, and press equals, we'll get something that looks a bit like the 66.422 to 3 decimal places. And if we tidy that up a little bit, round it to 1 decimal place, we get an angle of 66.4 degrees for this example. So here is where I'm going to leave an exercise for you to attempt, and we'll go through the solutions to this in class. In each of these two triangles, triangle XYZ and triangle DEF, you've been given an angle identified within the triangle and the length of 2 of the sides. What you're being asked to do here is to use the correct trig ratio, and we'll be using its inverse, find the size of the angle. So when we come into class this week, we'll work through both of these examples. You need to check your answers there, but definitely have a go and attempt these beforehand, because it will help you to underpin your understanding of this. So that's all for now. I'll see you in class not too long after you've watched this video, and we'll take some more problems there. And of course, I'll be happy to answer any questions.